Okay, this is the second video on experimental design, and we talked about the type of study, observational versus experimental, and then we talked a bit about variables. So now we're going to go into the nuts and bolts of different types of sampling. Again, the wordy PowerPoint, pause it if you like. But the reason we call it sampling is because we can't generally measure the entire population. If we're going to talk about Tuatua at the Mount Main Beach, and we wanted to know the mean length of the population there, we would have to go and measure every Tuatua down to 4 or 5 meters. We'd have to go and dig up the entire beach down to 4 or 5 meters and get every Tuatua and measure them all in order to know the actual length of the average length of those Tuatua population. So what we do is we sample, we go through and we take a portion and we try to make sure that we get a representative sample of across the whole of the population. And that's why we call it sampling, but in 99.99% of the time, that's what you're going to be doing. Very rarely, unless you're doing an experimental design in a lab or something, are you going to be able to measure everything. And the reason that that's important is because whether we do a good job of getting a representative sample of all the individuals makes a difference in whether we can be confident in reporting our findings as accurate. The first thing to think about when we're trying to figure out how to be accurate is replication. And if you are going to get close to the true mean, the true value of something, you could take one person and measure their height in a classroom, and you may or may not get somebody who's right in the middle. You might get somebody super tall or somebody really short. And so if you do 2, you're going to have a better chance of getting the true mean, and 3, a better chance of getting the true mean. And in general, the more samples you can take, the better you'll be. The more you'll have more statistical power and more confidence about your assertion of whatever you believe to be true about that population. So why is that? If you, like when in the last example, we talked about measuring somebody who was really short or really tall for the only person that you measured, and you might be in a classroom of say you're doing a nursing classroom and you measure the heights of people, and there are 18 women, and then there's one guy who's 6'8", and you happen to pick the guy who's 6'8". You're not going to happen to have a very good approximation of the mean height. So those are called outliers. Those are very far different, very different from the average, the typical individual. And by increasing the number of samples, you can decrease the influence of those outliers. But generally, when you're sampling, it takes a while, it takes time, it costs money. If you're going to send samples out to test nutrient levels, you might send water samples out to Hills Weller and Waikato, and maybe that thing costs $30 a sample. So unless you have a huge budget, you're going to be limited to how many samples you can take and send off. You're also going to be limited in the amount of time that you have in order to go out and take samples. So replication, you've got to balance the fact that it's better to have more versus what you can do practically. Our first type of sampling is simple random. Now, people say, oh, that guy's so random, or we use random all the time when we're talking in conversations. But random in science has a different meaning. It means that every possible test subject, every possible individual, everything that you could sample has exactly the same amount of being chosen as something else. And this is what we call a random design. So the random number generator is used. That takes all the bias out of the person deciding who will be sampled. So in this example, we grid out the there we go. We grid out the this crowd, all the seats, and we'd use a random number generator to pick this seat and this seat and this seat and this seat, and we'd use that. We'd get our samples by going to those seat numbers, and that way we wouldn't have any bias. We wouldn't pick just good-looking guys or pretty girls if you happen to be that way inclined, or the people who don't look intimidating to the researcher, or the first 20 that come out of the seats to go buy a soft drink or something like that, or a hot dog. So we want to try to eliminate our own bias, and we have bias whether we know it or not. So that was simple random sampling. This is convenience sampling, and this is where you just sample whatever is available. A lot of times people call this random, but it's not really random. So like in that last example, if you just hung out by the let's put a little marker here. If you just hung out here by the exit from the stadium seating, and whenever somebody came out to go to the toilet or go buy a beer or a hot dog or something like that, then you just say, hey, can I measure how tall you are? Or hey, can I take a blood sample? Something, yeah, it might get you punched, but you take just whoever's convenient. You might take the ones that say, yeah, that's fine. In which case you're not necessarily eliminating bias. If you're taking the first 20 that go to the toilet, they might be the ones with weak bladders, and you might not get the say younger, fitter people, or people who are wearing adult undergarments or whatever. There are you're going to have a little bit of bias in this, but often, in case you don't have that much time, you may just take the first of whatever shows up and sample those. Next, we have haphazard sampling. So if you took this dude and you gave him a gun, a paintball gun, and blindfolded him and said, shoot up into that crowd. Well, so you could take the first 20 people he hit with a paintball, and that would be your sample. Okay, so there's no real method there's no organized method of choosing who your samples are, and that is often called random, but it's not random, it's haphazard. So if you go down and throw a quadrat around on a mudflat, or you go into a forest or something, then a lot of times people will say, well, it's random sampling, but that's not. It's haphazard sampling. So science, random is only when you have a random number generator. And one of the things about haphazard sampling is that it's, this guy will probably be shooting right towards the middle of the crowd. Like most of his bullets will, let's try a different color. Let's go here. Now you can barely see it. Most of his bullets will or his paintballs will land kind of in the middle of the crowd, and maybe a little less on the outside. He's going to be aiming for where he hears the noise. So you're going to maybe miss some of the crowd along the edges, depending on how good his aim is. But in terms of real world, like we often will go out and it's easier to walk through some widely spaced trees than it is through a dense supplejack area. So maybe you're going to miss out on those dense supplejack areas if you're sampling in a forest and you're using haphazard sampling. And maybe in order to try to eliminate the problems with haphazard sampling, we might do something called systematic, which might be a little easier than using a random number generator, or maybe not. But it might be a little easier for the researcher actually doing the sampling in the field. You're still going to use a random number generator. So you use a random number generator to pick out a seat. And so perhaps you start with this one. And then you go every 20th seat. So 20 seats down this way and then this way, and you wind up with this one. And then you go into the next 20 seats. And every 20th seat you sample, and that's one of your data points. And this is called a systematic design. When you put something in, like if you're going to do a transect line and you put a quadrat every 5 meters or every 50 meters or something like that, then you are doing a systematic design, and that's a way of trying to overcome bias. Here's another one, stratified random sampling. So if we want to go, let's say we're going to go to the monster truck rally, okay, and we're going to sample the crowd. Well, there are going to be probably more men than women at a monster truck rally. I'm just going to go ahead and make a total generalization here. So we're probably going to say that if we want to measure the heights of all the people in the crowd, then we're probably going to or the heights of humans on the planet, and we decide to measure at this rally, we're going to underrepresent women in the sampling by going and choosing to represent at this one. So if we say we know that this crowd is 70% men and 30% women, maybe we take we decide that we're going to take a certain number of samples from one strata, and we're going to take a certain number of samples from another strata, and we're going to try to make sure that we representatively apportion our samples according to the size of these strata, so these groups. We couldn't call them strata, but they might be groups. Let's say that you're going to sample a forest and it's up a steep hill. So you might definitely want to do some samples at low elevation and some samples at high elevation. And that means that you're going to, you want to make sure that you're getting as many at each of the different elevations, and you'd call those strata. Okay, stratified random sampling. You're still, and since it has random in it, then of course you're going to be using a random number generator. So blocking is an interesting one. In just about every study, you have something called a nuisance factor, and the nuisance factor is something that's difficult to control, but can affect the outcome. So you arrange experimental blocks that are homogeneous for that nuisance factor. We'll have an example. We'll have a look at an example on the next slide, and then you do your randomized sampling treatment within those blocks. Okay, and this can be, it's not essential always, but it definitely improves precision. So if we think about this one, so we're going to look at the effect of trampling in a paddock. And this thread fern, though, it may be something that the cows don't like to step on because it's like scratchy on their hooves. Okay, so maybe when they the thread fin might affect where the cows are trampling, and so you're going to have blocks that are homogeneous for thread fern cover, and then you're going to apply your treatments to those, and then you look at the differences within those blocks, and then so like you can look at all the red ones here, and you've kind of controlled for that thread fern cover. But you're not only interested in what trampling effects are in just those low thread fern cover zones. You're looking at, you want to know what the trampling effects are across all of the whole paddock or different habitats. Okay, so you're going to do blocking where you control into so that the that nuisance variable is homogeneous throughout those blocks. This is an example that we do in class, but you can now take each of your sampling designs, your sampling types, and design an experiment to sample a certain number of these blocks at different elevations. Let's say you're going to do tree trunk diameters for each of those. So you could apply a random number, a simple random design, or stratified random, or how would you do a convenience sampling design. it's up, and you can stop here and try it out. And I realize this video is getting a bit long, so we're just going to quickly measure this. You can stop and read this. Frequency tables are a way that we often record data. You have one category across the top, and then something across the bottom of the side, and then you just mark how often it happens. For example, how many did you see, and what hour did you watch? So that for the first hour, you recorded 1 tui, and then the second hour you recorded 1 tui, and the third hour you recorded 6 tuis. This is called a frequency table. And then you can do the same, the frequency or the number seen. There were 5. You went and measured a bunch of them. You caught a bunch of them, and 5 of them were between 40 and 45 millimeters. 2 of them between 45 and 50 millimeters. 3 between 55 and 50 and 55, and so on. So now you can stop and go to the review and the questions in the book, and work on those. There's a summary of the last two the 2 lectures. Planning your experiment is super important, and you need to know the steps of the scientific method in order to be able to do that. This one was really about your hypothesis and designing your experiment, and you're going to need to know the variable types. You're going to do the questions in the workbook, and these dates, depending on whether this year or not, will maybe different. But yeah, get into the Moodle quizzes.